In this lecture, we will learn about excess pressure. So basically what happens is, if we consider a liquid bubble like this, so let us assume the pressure outside, that is the atmospheric pressure, be PA, and the pressure inside, that is the pressure inside the liquid bubble, is PI. So what happens is, it has been observed that PI is slightly greater than PA, due to which this liquid bubble expands a little bit. It's like this. So due to this difference in pressure, the liquid bubble expands, and the value PI minus PA is called as excess pressure. So basically the pressure inside a liquid drop is greater than the pressure outside, that is PI greater than PA, and now excess pressure is basically the difference in the pressure, which is equal to PI minus PA. So we will derive mathematically what PI minus PA means. So for that, whatever we have assumed, we can write like PI is equal to pressure. PI is pressure inside the drop or the liquid bubble, whatever you can tell, that is all fine. PA equal to pressure outside, or you can tell it as atmospheric pressure. Atmospheric pressure. So let us derive. Let's say this is my liquid bubble, fine, and pressure inside is PI, pressure outside is PA. What happens? It will expand a little bit. So I will show the expansion like this. Let's say due to the excess pressure, this expands like this, and let the radius of the liquid bubble is R, and the area of this liquid bubble is S. Let the increase in the radius be delta R. Therefore, the increase in the surface area be delta S. So this much assumption we can make. After that we will proceed. So basically formula for surface area is equal to 4 pi r square, since it is a spherical drop. So surface area is 4 pi r square. And now we know that delta r is the increase in the radius. Delta r is increase in radius. Therefore, final surface area will be this surface area plus delta S will be the final surface area of this final bubble. So I will calculate that. That is equal to S plus delta S, which becomes 4 pi R plus delta R square. So I will simplify this little bit, and this becomes S plus delta S equal to 4 pi. Let us expand this. So I will be getting R square plus 2 R delta R plus delta R square. So let us multiply S plus delta S equal to 4 pi R square plus 8 pi R delta R plus 4 pi delta R square. Now as we can observe that this S is equal to what? 4 pi r square. So instead of 4 pi r square, I can write this as S. So this S and this S will cancel out. Therefore, finally, delta S becomes 8 pi r delta r plus 4 pi delta r square. Now, one more thing we can observe that the value of delta r is very, very small. The value of delta r is very, very small because this increase in length is so small that we cannot even observe from our naked eyes. So delta is very, very small. That definitely means delta r square should be more smaller than this, because a square of a number less than 1, let's say 0.001, if I square this, then it will be very less number as compared to this. So if delta is very small, that implies that delta r square can be neglected. Delta r square can be neglected. So finally, the expression for S becomes, 8 pi r delta r, because if delta r square is neglected, this becomes 0. So this whole term is 0. So finally, this is the only remaining term. So S becomes 8 pi r delta r. Sorry, it's not S, it's delta S. S has got cancelled out, so delta S becomes 8 pi r delta r. So proceeding forward, the formula for surface tension is equal to delta U upon delta A, where delta U is change in potential energy, delta A is change in surface area, and T is called as surface tension. Therefore, from this formula, I can write delta U equal to T into delta A. This implies that delta U equal to T into, and delta A, just now we calculated delta A, that is the change in surface area, 8 pi r delta r. So I can write 8 pi r delta r. So basically this is the change in potential energy, right? That therefore the change in work done, as we know that potential energy is equal to the negative, change in potential energy is equal to the negative of work done. So I can write delta W is equal to T into 8 pi r delta r. And the formula for work done is also force into displacement. So therefore finally I can equate it as 8 pi r delta r equal to force into displacement. Now instead of force, I know that pressure is equal to force upon area. So force is equal to pressure upon area. Now since we are calculating the change in pressure, so this becomes delta F and this becomes delta P, and delta P is nothing but Pi minus Pa, which is the change in pressure. If this is the liquid bubble, Pi is inside and Pa is outside. So the change in pressure is definitely my Pi minus Pa. And if this is the delta W, I can substitute directly. So Pi minus Pa, Pi minus Pa into area into distance, or instead of distance I can write as this as delta R, because since it is delta W, so this should be delta S. So delta S here is my delta R, as we can see from the figure in the last slide. As we can see from the figure, here the delta R is only the change in length. So I can replace with delta R. And this is equal to what? T into 8 pi R delta R. So finally, Pi minus Pa into the formula for A is, we can substitute formula for A, that is 4 pi R square into delta R equal to T into 8 pi R delta R. Therefore, I need to calculate Pi minus Pa. Hence, Pi minus Pa becomes, whatever is getting cancelled out, I will just cancel out this 1, 2, pi got cancel out, R square and R got cancel out. Here R will remain like this. Delta R got cancel out. So finally, I got 2T upon R. So this is my final formula for excess pressure in a liquid bubble, where T is the tension and R is the radius. R is the radius and T is tension. Okay. So just a small topic to discuss on this. If it is a liquid bubble, then it is inside, it is filled with liquid, and outside we have air. So for liquid bubble, just now we derive the excess pressure is 2T upon R. So this becomes excess pressure, that is delta P, equal to 2T upon R. For air bubble, it is filled with air inside, and let's say outside it is filled with liquid. Outside it is filled with liquid. This one is liquid surface. So the same for this delta P equal to 2T upon R. But there's a slight change in soap bubble which I would like to discuss with you all guys. So in soap bubble, what happens is, only soap bubble is made up of a layer which is called liquid layer or the soap layer. Only this much of layer is what? Your liquid surface, and this layer is air. Inside it is filled with air, outside also it is filled with air. So this is what actually happens in case of soap bubble. Now as you can compare, in this bubble, how many air surfaces of air are there? Only one surface. So 2T upon R. How many surface of air are there? Only one surface. So 2T upon R. How many surface of air is there? 1, 2, two surface. So here the only change in formula will be delta P is equal to 2 times 2T by R, which is equal to 4T by R. So that is all for this lecture. See you in the next video.